Hello and welcome back to Unit 6. We're going to begin Part 2 now, which is all about factoring polynomials. So you just learned how to combine them by adding, subtracting, and multiplying, and now we're going to learn how to pull them back apart. So this first assignment is focused on finding the factors by taking out the GCF, or also known as the greatest common factor. All right, so a couple notes about factoring by the greatest common factor. One is that you always want to try and factor out a greatest common factor first. So no matter what type of polynomial you're working with, look and see if you can take out a greatest common factor first. We're going to learn some more complex ways of factoring. And so you might be able to use those afterwards or instead of greatest common factor. But if there is a greatest common factor, it's going to be helpful for you to take that out at the beginning. The other idea is just to remember what a greatest common factor is. So when you're looking at numbers like you did back in elementary school, well, a factor is anything that multiplies to that number. So if we're trying to find factors of 10, well, things that multiply to 10 are 1 times 10 and 2 times 5. So 1, 10, 2, and 5, those are factors of 10. Then if I want to do it for the number 5, let's say, the factors of 5 are just 1 and 5. So when I want to look for common factors, the common factors that they have are, well, they both have a 1, and they both have a 5, so those are both common. The greatest common factor is going to be the biggest of those two, so the greatest common factor here is 5. And so that's what you're really doing when you're going to be factoring, but you're going to be doing it with a polynomial instead of two individual numbers. And you're just trying to figure out what the greatest common factor is and divide that out of both of your polynomials evenly, or your polynomial. So, going back to what you did in the last section, the last part of this unit, you were multiplying polynomials together. And so if you're presented with a problem like 3 times x minus 5, well, this tells us to distribute. So we would end up with 3x minus 15. All right? And that would be the answer to your problem. What we're going to do now is start with the simplified version, 3x minus 15, and we want to factor it out. So we're going to be pulling out a number, and factors are all multiplication. So when you pull out that number or variable, it's going to be multiplied by whatever else would be left over. So let's start by looking at the numbers 3 and negative 15. Well, I know 1 times 3, those go into 3. 1 times 15 and 3 times 5, I'll go into 15. So the only one they have overlapping the two that they have overlapping are 1 and 3. Both of those numbers go into 3 and 15. The largest one is 3. So when I factor, I'm going to put my greatest common factor out front, which I just determined was 3. And then in parentheses, because it's all multiplication, I want to write down what I would have left over after I divide the greatest common factor out of both or all parts of my polynomial, all terms. So if I took out the 3, because that's my greatest common factor, then for the first term, I'm going to say, okay, well, what is 3x divided by 3? Well, it's just x. And then for the second term, what is 15 divided by 3? And that's going to be a 5. And because it was negative 15, it's a minus 5. So your factored form is 3 times x minus 5. Well, if you look at that, isn't that what we started with up here? So all we're doing when we factor is just we're reversing the distributive property. We're undoing the distribution so that we can use these factors. These will be helpful to us when you're graphing quadratic functions or other polynomials. Oops. So let's try another one here. We have 10x minus 4y. That's my equation, or my expression. Another note to keep in mind, you're not solving for anything, you're just rewriting it. So we're not going to have like x equals 5 at the end. We just want to rewrite our expression. And so 10x minus 4y, well, start by looking at the numbers. Between 10 and 4, the highest number that goes into both of them is 2. So I'm going to start my greatest common factor with a 2. You also want to check for variables though, but in order to take out a variable, both terms have to have the same variable. In this one, 10 has an x, and the second term only has a y. Well, there's nothing that's common to both terms, so if it's not common, I can't take it out. So then I begin my parentheses and say, all right, well, my first term, 10x, I'm going to divide it by 2, because that was my greatest common factor, and that leaves me with 5x. My second term is a negative 4y. I'm going to divide that by 2, my greatest common factor, and I get negative 2y. So your factored form is 2 times 5x minus 2y. They are the exact same expression, you're just rewriting the second one so that we can work with it in a different form. Alright, so the next one here, we start with our numbers, 6 and 8, and the highest number I noticed that goes into both of those is 2. So 2 is going to be part of my greatest common factor. And then we want to check out the variables. Well, I have x squared here, which is, there's 2 x's, right? X times x. And I have x cubed here, which means there are 3 x's. So these factors of x squared are x, and x cubed is x, and x. The most you could take out that they have in common, they both have 2 of the x's. Right? So the greatest common factor here is going to be 2 x's, or x times x, which is the same as x squared. And then if we take that and take each of our original problems here, let's get rid of this for a second. We're first going to divide our first term by the greatest common factor, 2x squared. Well, 6 divided by 2 is 3. And x squared divided by x squared cancels. On the right hand side, 8x cubed divided by 2x squared. 8 divided by 2 is 4, and a positive 4 because it's positive 8. X cubed divided by x squared, remember when we divide we're subtracting our exponents. So 3 minus 2 would leave us with x to the first, or just x. So your final answer is 2x squared times 3 plus 4x. So you always want to take out the lowest amount, the lowest power of your variables, as long as they all have that, at least that power. Alright, so since x squared was the 2 was our lowest power, and 8x cubed also had an x squared within it, then we can take that out as also part of our greatest common factor. Another way to check and see if you're right, check yourself, is to take what you just did and distribute it back through. If you factored correctly and you do this, you should get the exact same thing you started with. Well, 2x squared times 3 is 6x squared, and 2x squared times 4x is 8x to the third. So we end up with the exact same thing that we started with, which means, yeah, we did that correctly. All right, let's try one that's a little bit more complex. So looking at my numbers first, negative 5 and 15. 5 and 15, well, the highest number that goes into both of those is a 5. So I'm building my greatest common factor here. Usually, when your beginning term is negative, you want to also try and take out the negative. So if your lead coefficient is negative, factor out a negative as well. Then we're going to look to the variables. So starting with the x's, here I have 2. And then down here, there's an imaginary 1 there, right? That 3 only goes with the y. So in the first term I have 2, in the second term I have 1, so the most that I can take out safely without ruining my problem is 1, the lowest amount, the lowest power that we have. Then I'm going to look to my y's. Here I have y to the first. Here I have y to the third. So again, the most I can take out is 1 because the first term only has 1 in it. So we can also take out a y to the first. And then in our leftover area, well, when I take a negative 5x squared y and divide it by negative 5xy, the negative 5's cancel, the y's cancel, and x squared divided by x is just x, or x to the first if you want. Down here, when I divide it by negative 5xy, 15 divided by negative 5 is negative 3. X divided by x cancels, and y cubed divided by y is y squared. So our final answer would be negative 5xy times x minus 3y squared. And it's all factored, so it looks pretty complex, but as long as you take it step by step and think about it as the reverse of distributing, you'll be fine. And so the last one I want to look at, 10x minus 3. When you look at the numbers 10 and 3, well, there's nothing that you can take out of those except for 1, right? 10 is 1 times 10, 2 times 5, and 3 is just 3 times 1. So I can take out a 1 for a number. And then the first term has an x, but the second term has no variable. Well, if they don't both have an x, then I can't take it out. So my greatest common factor is just 1, and then in the parentheses, that would still leave me with 10x minus 3, because I'm not dividing anything out. So when the only thing you can take out is a 1, this polynomial is considered to be prime, because the only factors are 1 and itself. So you can call that prime. You can also write it as 1 times itself, but usually that's understood as long as you say that it's prime. So go ahead and try your worksheet from assignment 6, or this is assignment 6 from part 2 of unit 6. Lots of numbers there. You're only doing the odds on that paper, and then the answers will open up afterwards, and you can score yourself.